Imagine you're standing behind a wall made of frozen water while high-velocity projectiles shatter against the surface and your fortress remains completely unharmed. Sounds epic, right? But let's be real. Most of our childhood snow forts were sad, amorphous piles of powder that collapsed under the first incoming snowball, leaving us totally exposed and defeated. Today, we're gonna fix that. This common disappointment stems from the fundamental physics of loose snow. It's inherently weak because individual flakes have minimal contact points, preventing them from distributing mechanical stress effectively across the structure. When you apply even a small amount of force, these delicate, unconnected flakes simply slide past one another, causing the entire construction to crumble into a heap of fluffy white particles. Now, let's dive into the fascinating molecular difference between that weak, loose snow and the truly bulletproof snow we're after. Loose snow consists of countless individual ice crystals, each a unique, intricate snowflake, just resting on one another with very little actual bonding, creating tons of air pockets throughout the mass. In stark contrast, bulletproof snow features ice crystals that have melted and then refrozen together, forming strong, interlocking bonds that create a dense, cohesive matrix. These tightly packed and interconnected ice molecules effectively distribute impact forces across a much larger area, preventing localized shattering. This transformation provides protection not only against biting winter winds, but also against serious physical impacts, turning a simple frozen substance into an architectural marvel. To truly understand the engineering behind these structures, we need to examine the core principles: compression, density, and strategic layering. This is way more sophisticated than just packing snow tightly with your bare hands, a method that leaves too many air pockets and insufficient bonding. Effective snow fortification begins with compressing the snow, forcing out those weak air pockets and increasing the overall density, which significantly enhances structural integrity. Strategic layering involves building the wall in successive, well-compacted layers, allowing each layer to settle and bond before adding the next. This creates a monolithic structure that acts as a single, unified defensive unit capable of withstanding considerable pressure and impact. Here's the crucial question: why do walls crumble? The answer lies in interlocking crystals, which are absolutely essential for creating a stable and enduring snow fortification. Those delicate flakes of fresh snow become an immovable barrier only through specific engineering steps that encourage them to bond together on a molecular level. This transformation happens by applying pressure, which breaks down the delicate arms of the snowflakes and forces them into closer contact, and then allowing for sintering or refreezing, when compacted snow experiences slight temperature fluctuations, or even just time. The individual ice crystals partially melt and then refreeze, forming strong, microscopic bonds that effectively glue them together into a solid, cohesive mass. This creates a dense network of interlocking crystals, distributing stress throughout the entire structure and preventing localized failure. Understanding the foundation of material strength is the first step, but now we gotta look at the actual techniques for achieving maximum density. This requires more than just stepping on the snow, because simple foot pressure creates weak points and dangerous hidden air pockets. Stomping your feet distributes your body weight unevenly across the surface, leading to inconsistent compaction and leaving numerous voids within the wall. These hidden air pockets act as critical failure points, making your entire fortification susceptible to sudden collapse. The superior technique involves meticulously tamping the snow layer by layer with a flat-bladed shovel for a far more effective result. The physics are straightforward. The shovel's broad, flat surface distributes applied force much more evenly across a larger area. This consistent application of pressure ensures individual snow crystals are pressed together tightly, minimizing voids and maximizing the crucial contact points between them. This method effectively eliminates those dangerous air pockets, creating a uniformly dense and incredibly stable foundation for your winter fortress. Moving beyond simple compaction, there's the highly effective snow wetting technique, which will dramatically enhance the structural integrity of your completed snow blocks. This involves lightly misting a small amount of water over your carefully placed snow blocks, initiating a rapid freezing process that binds the individual snow crystals together with remarkable strength that you can't achieve through compaction alone. The strategic addition of water significantly increases the density and overall cohesion on a molecular level. As the misted water freezes solid within the snowpack, it fills the microscopic gaps between all the snow particles, forming tiny ice bridges. These countless little ice bridges act as a natural cement, effectively fusing the entire structure into a more unified and resilient mass. This technique is especially valuable for reinforcing critical sections like battlements or load-bearing walls. The resulting ice-bonded snow becomes incredibly resistant to shattering and erosion, providing a superior defensive barrier. The true unsung hero of winter engineering, however, is the magic of sintering, a fascinating natural process that fundamentally transforms snow. Sintering describes the slow, gradual growth of tiny necks or ice bridges that form between individual snow crystals over time. This occurs as water molecules sublimate from convex surfaces and then refreeze at the concave contact points between crystals. Over many hours and even days, this microscopic bonding process dramatically increases the overall strength and rigidity of your entire fortification. It turns what was once a collection of loose, individual flakes into a solid, ice-like material with incredible defensive properties. Understanding this natural process is crucial because it explains why patience is a fundamental engineering principle. This natural welding fundamentally transforms the snow's internal structure, creating a robust and resilient defense. Here's what's crazy. A freshly built snow fortification, despite your best tamping efforts, remains relatively brittle and structurally weak, highly susceptible to damage from impacts. However, after a full 24 hours, that exact same structure undergoes a profound change, becoming incredibly solid and resilient due to continuous sintering. The microscopic necks between flakes grow much stronger and more numerous, creating an interconnected crystalline lattice that distributes incoming stress much more effectively throughout the entire structure. The fort literally heals and strengthens itself over time, turning from a temporary shelter into a nearly impenetrable ice wall without any further intervention. Now, while sintering creates this monolithic structure, we need to compare this method against using traditional ice bricks. When constructing winter defenses, a crucial analysis between ice bricks and densely packed snow reveals significant differences. Ice bricks seem strong, yet they possess an inherent brittleness that makes them incredibly prone to cracking, compromising the structural integrity of your entire fortification very quickly after just a few direct hits. Conversely, densely packed snow exhibits remarkable energy-absorbent properties that allow it to withstand impacts. This forgiving material effectively dissipates the kinetic energy from incoming threats without catastrophic failure, providing a much more reliable and durable defensive barrier. Picture a high-speed projectile striking a wall made from solid ice bricks. The immediate result is a spectacular, explosive shattering of the ice. This catastrophic failure happens because the rigid crystalline structure of ice lacks the necessary flexibility to absorb and distribute the immense kinetic energy of an impact, leading to rapid structural breakdown right at the point of contact. Now, visualize that same projectile hitting a meticulously crafted wall of sintered, densely packed snow. Instead of shattering, it simply buries itself deep inside. The projectile's energy is gradually absorbed and dissipated throughout the porous yet incredibly dense material, effectively neutralizing the threat without compromising the wall's integrity. The physics of this superior energy dissipation involves countless tiny air pockets and ice crystal bonds which deform and compress upon impact, converting the projectile's kinetic energy into harmless heat and sound. After meticulously constructing your robust snow fort, the next critical phase involves mastering the art of camouflage and stealth. Begin by strategically covering the exterior with various natural textures and shadows found in the surrounding frozen environment. You can accomplish this by draping snow-laden branches or scattering loose snowdrifts, which helps break up its distinct and recognizable outline. The primary objective is to break up the silhouette of your stronghold, ensuring it seamlessly blends into the frozen, monochromatic landscape, making it incredibly difficult for any approaching enemy to discern its presence from a distance. Utilize the natural play of light and shadow during different times of the day, positioning your fort where shadows naturally obscure its recognizable form. A perfectly camouflaged snow fort becomes an integral, indistinguishable part of the winter environment, effectively disappearing from plain sight. Our incredible journey from understanding loose powder to constructing a bulletproof bastion has been an exploration into the fascinating physics of winter fortifications. We've learned that the simple act of compacting snow transforms fragile crystals into an incredibly resilient, energy-absorbing material far superior to brittle ice, providing unparalleled protection against high-velocity threats. The strategic application of camouflage ensures that your formidable creation remains an unseen, silent guardian. This comprehensive understanding of material science and environmental integration elevates your snow fort into a truly legendary winter stronghold, a testament to your ingenuity and complete mastery of the fundamental natural elements found within the frozen landscape. By mastering the science of density and the magic of sintering, you can transform a simple pile of snow into a legendary winter fortress.